All right, so if I tell you these two triangles are congruent, you should be able to give me some facts back. True facts. Triangle ABC congruent to triangle DEF. And just make sure we're good here. Triangle ABC congruent to triangle DEF. One fact that's true? One fact? Miley, hi. So just name two for me. Okay, A is congruent to D. Everyone agrees? So is B and E. Are those the only things that are congruent? Give me another something that's congruent then.
Okay.
I know C and F. I don't need to know those. Fia?
Do you like what line BC is congruent to EF?
BC and
Yeah.
EF. There you go. And all the other corresponding sides. So all the angles are equal and all the sides are equal and the triangles are congruent. Now what I want to show you is what's the deal when two triangles are similar? Because this right here, doesn't happen if two triangles are similar. Something else happens now. First thing I want to introduce you to is the symbol for similar. You guys know the congruent symbol? Yeah. Take away the equal. Are you imagining in your mind what's left? Yeah. That's the similar symbol. Right here. And have some self-respect. Don't call it a squiggly. Anybody know the official name of that? What is it? Tilde. All right, it's called the tilde. All right, not a squiggly or the worm, called the tilde. All right. So let's talk about now if two triangles are similar. So let's get triangle ABC and DEF back up here. And my statement to you guys will be, hey, triangle ABC, you know what habit you're going to have to break big time? Everyone's going to have a habit of putting what next? The congruent symbol. Just keep it in the back of your mind. It's going to be tough to break that habit, but similar to triangle DEF. All right, now, what happens if two triangles are similar? Well, good news. The angles are still equal. A and D are still congruent to each other. B and E are still congruent to each other. What changes? Hey, everyone, sides aren't equal anymore. The sides are not equal if the two triangles are similar. Instead, the sides are in the same ratio. Watch. I'm going to say AB is 5. AC, what do I have there? AC, 10. BC is 8. So those are the three sides of that smaller triangle. Now, the sides over here are not 5, 8, 10 anymore. Ready? 15. Can you now tell me the side length of DF now? They're in the same ratio. So 5 to 15 is in the same ratio as 10 to, what's got to be DF then if they're all in the same ratio? 30, yeah, now we're picking it up a little bit. The sides aren't congruent in similar triangles. They're in the same ratio. And then EF would have to be what to keep consistent? 8 and 24. There we go. All right, so see the difference between congruent, which are all equal, and now similar, which they're all in the same ratio. All in the same ratio. And that ratio is called the scale factor. The scale factor, which means the ratio of two corresponding sides. That's the ratio of two corresponding sides. So can somebody give me two corresponding sides up here? Give me two corresponding sides. I'm going to go back to my numbers here. Even though I know I'm missing a few here, but it's fine. We should be able to get it done. Been a little bit. 23. Just give me two sides that match up, Lucy. That's it. Yep, so 5 over 15. There's your scale factor. If you want to reduce, sure. What's that reduced down to? 1/3. So we say the scale factor for these two triangles is 1/3. Would it still work if Lucy picked two other sides?
Yeah.
10 and 30, 8 and 24? Yes. They're all in the same ratio, which is called the scale factor. Questions right now about if two triangles are similar. All right, before I move on, let me go back to my congruent triangles, because this is the easiest way for me to teach you guys the similar stuff. Anybody know what I'm going to ask? Five what?
What? The 5 ways to find like the triangle.
5 ways to prove them. What were they?
I'd say side, angle, side, angle, side, hypotenuse, side, and
The easiest. 5 ways. Similar? 3. There's only 3 ways to prove triangles similar. And I think you'll like the first way a lot. The first way, AA, which stands for angle, angle. So all you need, this is what it's saying. All you need, 2 pairs of angles congruent, they're similar. Done, done, done. 2 pairs of angles congruent, the triangles are similar. See my diagram? Everyone see the 2 pair I marked? Those are similar now. Those are similar. So take a look at my new one down here in the example. Using a short 2-column proof, statements, reasons. This is going to be a big topic on Monday, not today, but just a short proof proving these triangles similar. All right, how can I prove these 2 triangles similar? Well, I know it doesn't have a given, but what did I put? What 2 angles are already congruent up here? H and S. We already, that's our given right there. They're putting 45 at each. H and S are equal. That's given. All right, don't overcomplicate things for me. Anything else up here congruent? Don't overcomplicate it. Anything else in that diagram congruent? Oh, 3.
Angle UOH and angle EOS are
Yep.
vertical angles.
Vertical angles are congruent. All right, do I have 2 pairs of angles? I'm done then. Guess what I know about the triangles? They're similar. All right, as long as you have 2 pairs of angles that are equal, they're similar. Triangle UOH. Look at your papers. Look at your papers. It's going to be a habit. You got to break it. Similar, not congruent. Similar to EOS. I won't get on you now, but sooner or later I'll start getting on you about having self-respect. Angle, angle. That's not bad. Just find 2 angles and we're good. So there's method number 1, angle, angle. Questions? Method 2, to proving triangles similar. It looks familiar, doesn't it?
Oh wow, it does.
Side angle side. Looks pretty familiar. But it means something different though. It means something different. You still need a pair of angles congruent. So in my diagram here, what are the angles that are congruent? R and S. Okay, so you still need a pair of angles equal to each other. So I have angle R congruent to angle S. Still need that. But here's the thing. The sides around it aren't congruent. They should be in the same ratio. All right, the sides around won't be congruent. They're in the same ratio. Here's what I mean. Everyone see the 10 in triangle red? 10 would match up with the 15 in the other side. So that creates a ratio of 10 over 15. Is that the same ratio as the other 2 corresponding sides? 12 over 18. Is this, I don't know. Is this true? Do you guys know how to understand or figure out if 2 ratios are equal? Because right now they look totally different, right? 10 over 15, 12 over 18. Anybody got methods to see if they're actually the same? What do you got? Reduce them. Yeah, reduce them. If you grab your calculator real quick, grab your calculator. Put 10 over 15 in a fraction template. So alpha y equals 10 over 15. And then hit enter, see how it reduces it for you. And now do 12 over 18 in a fraction template. Do they both reduce down to the same thing? Yes. Okay, so that's how you can check. Right on your calculator. It'll do all the work for you. Just put it in a fraction template. So does everyone see the sides around the angle have to be in that same ratio? All right, let's go to my example then. Why are these triangles going to be similar then? Do you know an angle already that's congruent? We know a pair? Name them. What's the angle that's congruent up here? Don't say anything yet. Coming up. Oh, 24. Good talk. 12. What two angles are equal up here?
Angle A and angle B.
Angle A congruent to angle D. This is not a proof. I'm just saying, hey, angle A is congruent to angle D. If this is going to be side, the sides around have to be in the same ratio. So 8 over, what's the 8 correspond with in the other triangle? 23? 6? Is 8 over 6 the same ratio as 19? Name another side in the triangle ABC. 4 over 3. I don't know. We can check though, right? We just showed how to check. 8 over 6, is it equal to 4 over 3? Good? Yes, it is. So guess what? Triangle, let's write it out now. Triangle ABC. Uh-oh. Second time. Lightning going to strike twice. Similar to triangle EDF by what method here? Not angle anymore. Side angle side. Now here's the thing, and see if anybody can tell me why I'm going to require this. You have to have the tilde after this one. Have to. Anybody know why I'm going to request that? Zach? Yeah, if you didn't put the tilde there, that's side angle side for congruent triangles. That's not what we're doing. Similar, right? So make sure you put the old tilde there. Questions, comments, concerns? So what was our first method? Angle. Second method? Side angle side similarity. And now the third and final method should look also familiar. Side. But does that mean all three sides are congruent? No. That means all three sides are in the same ratio. All right, all three sides now are in the same ratio. So look at my example here. Why would these two be similar by side? Give me a side from one of the triangles. Give me any side. I don't care. Give me any side here. 15. Okay, so I'll go 8. All right, 8. Now look, I don't blame you guys. If I ask somebody right now, what would the 8 match up with on the bigger one? And you'd be like, I don't know. You got lots of choices. Let me put a nice easy way for you. Smallest side always matches up with smallest side. So if 8's not the smallest side in this triangle, it's the second largest one, I guess. What would it match up with then, using my rules on this triangle? 16, right? VS. Does everyone see that? Is that the same ratio as, let's go, pick another side for me. 5. What's the 5 going to correspond with? 10. Now, it's looking pretty good, right? But what's the name of this method? Side. You have to check the third. I don't care if this works. It's not the side method. It's side. So we also have to check if 13 and 26 are the same ratio as the other two. And some of you might do that in your head. Some of you can go to the calculator. It doesn't matter. Whatever gets the job done. Are they all in the same ratio?
Yeah.
Yes, they are. Okay? Yes, they are. By side. So angle, side. And I wanted to introduce you just to the last. This is like I call it desperation method. All right, desperation method. I guess I'll call it number 4. If in a proof, you can prove the triangle's congruent, therefore they're similar. If the triangles are congruent, they are also similar. Right? Sometimes you might be looking at a proof and be like, oh my God, I can't do this. I don't even know how to prove these similar, but I can prove them congruent. That means they're similar. Okay? Very not used a lot, but if you can do it. All right, we're ready for a little group work. One at a time here. Number one, talk it over in your group. Are they similar? Right, first of all, I want to know, are they similar? If you're going to say yes, write me the similar statement and the reason why. No proofs. Just say yes, triangle so-and-so, similar to triangle so-and-so, and give me the method. If you're just going to say no, just write no. Go ahead. On number one, talk it over. What do we think on number one? Are they similar? If you're going to say yes, give me the statement and the method.
Just the first one?
Just the first one, yep. Here you go. You guys hopefully had a chance to discuss it. Oh, 6, yes or no?
Yes.
Yep, they are. Now I'll write triangle AXB similar to triangle RXQ. Hey, everyone look at your paper, self-respect, right? Everyone got the tilde, not the congruent symbol. And what method there, this first group?
Angle.
By angle. Yep. Where's the other pair? Vertical angles, right? The given pair and the verticals. Everyone all right? Angle. Back to your group. How about number 2? Are they similar? Ooh, this is going to be a tougher one now. Come on. Be ready to prove yourself. The sides don't need to be congruent. They need to be in the same ratio. So you better check. I like the discussions here. I like it.
Yeah, but then the other two Hey John, 16 and the other side.
Yeah.
It's gonna be like side.
Oh, is it?
If it is.
No, you're fine. Have a good day. Good weekend if I don't see you. All right, what do you got for me? Don't have one. 7, we have a 7.
Yes.
All right, I got a yes, which is correct. Let me just write my statement first. Triangle XPM similar to AWL. All right, what method?
Side.
Okay, that one way. If you matched up all 3 sides, they would be in the same ratio. Anybody do side angle side because you had the right angle. You could also do side angle side. Anybody want to go over why they are in the same ratio? Anybody want to see them matched up to test? Sure, we're okay. All right, moving on. Number 3. Go ahead. Are those similar? Are those similar?
But it can be any two.
Yeah.
All right, what do we think on this one? Oh, 11s? Don't have one. 16?
No.
No, they were not. You did have vertical angles, but when you matched up sides, they would not be in the same ratio. So this could not be side angle side. And there's the other two methods aren't even an option. It was only side angle side. Everyone good? Feeling all right? Seeing if they are similar or not. We're okay. Any questions? All right, let's move on to something different. I'm actually going to skip over number 1. We're going to come back to it. I want to actually set up one here. Number 2. We'll do 2 and 3 first. We'll do 2 together, and then we'll do 3 in your groups. All right, so for number 2, see what they tell me? You don't have to prove it to me. I'm telling you they're similar, which means what about their sides? They're set up in the same ratio. If the triangles are similar, they're set up in the same ratio. They tell me all the values, and we are in charge of finding the length of ML. ML. What's the length of ML? All right. The triangles are similar, so sides are in the same ratio. Guys, this is going to be the toughest part of the unit, is you finding your own ratio to build. Let me try to help you out right now. Here's how, again, this is how I do it. It doesn't have to be the way you do it. I take one of the triangles. I take the triangle where I'm trying to find a side. So I'm going to take this smaller triangle. What are my two sides? X and 7. So I do X over 7. Then I try to match up each side in the other triangle. So I say to myself, what side would X match up with over here? Because that length's going to go right here on top. Now, it might be tough for you. Look, even as a math teacher, I struggle visually trying to put things on top of each other and what's going to match up. You know what gets me through this? The statement. Because remember, it's written like that for a reason. ML, everyone see where ML is? What matches up with ML over here? QR, done. I don't have to visually do it. It matches up with QR, which is how long? 30. And then what would the 7, LN, match up with? Use your statement if you don't like it to move it visually. LN matches up with LNN. QR, how long's QR? It's not QR. QS, which is? Everybody stop. Pencils down, please. Some of you may not write it like this. Maybe some of you do this. You start with X and you put it over 30 to the side matches up with. And then you say, all right, give me another side from the small triangle. 7 over, what did 7 match up with? Those are the same things. Are you cross multiplying the same numbers in both proportions? Yeah, so that's okay. I just want to show you there's different versions. You do what you're comfortable with. Go ahead, solve it in your group right now and move on to number 3. Just be lucky there's no factoring or quadratic formula yet when you solve this. Cross multiply, solve for X, and then you guys move on to number 3. Give you guys another couple seconds, and then I'll ask somebody what their proportion was that they set up to solve for the smaller side.
X over 4, 36 over 9.
My biggest worry in this unit with you guys is setting up a correct proportion. How's it going with this, number 3? How's it going setting up your proportion? All right, can I hear your proportion that you set up? 3?
I have, I think I have the one.
Ready? Here's where your process should be, Jackson. Ready? The triangle we're trying to find a side for. Name 2 sides off it. X and what else?
Wait, say that again?
Okay, the triangle we're trying to find a side length for. Name the 2 sides I know on that triangle. Okay, so X, that's how it started off. X and 36. Now I got to put across what's X match up with if that's I'm looking for the shortest side. 4. 36 is the longest side. What's it match up with the other triangle? 9. All good? Okay, look, anybody set up a different one? Are you still cross multiplying 4 and 36 and X and 9? Then I'm good. I'm fine. Perfect. Doesn't have to be this one. As long as you are cross multiplying 9 and X and 34 and 6, boy. Why am I? That's 144, right?
Yeah.
So X would equal times 4, 16. Talk to me here, setting up the proportion. It's the toughest part. Again, you see how I do it. I start with 2 sides of a triangle, and then I match them up across from them. All right, go back to number 1. There you go. In your group, this is going to be the toughest one. The 2 triangles are similar. Only one proportion is correct to solve for X. Only one proportion is correct to solve for X. Which one is it? Number 1. Some numbers are in the wrong place. Some things don't match up. Other different ways to do a proportion.
Oh.
No, X would be.
Well, yeah.
Think we had a correct one? Think we found the correct one up here? What do we think? I got to vote for 3. Well, this group obviously had 3, so 4. Other votes? I got 3 and a 4. Okay, let me start with number 4 then. 32, ready? 32 over 12. That matches up, right? Everyone's all right? The 32 and the 12 match up. So I'm okay with the first part. Here's where I'm not okay with. Setting any, why can't I put 15 on top there? Do those come from the same triangle? No, they got to come from the same triangle. Okay, if I'm doing it this way. So that did not work, number 4. But yes, you are correct. Watch, 30, ready? 32 over x came from the same triangle. What's 32 match up with? Perfect. And what's the x match up with? 15. Good. Anybody want to go over 1 and 2? Why it would be incorrect? They got to come from the same triangle and correspond. All good? I know this is going to be tough tonight. All right, and then we got one more problem, right? All right, I don't want to read this thing out here to you. I want you to see it in numbers. I want you to see it in numbers. So can you do this for me? On quadrilateral ABCD, can you put AD as 1, AB as 2, BC as 3, and DC as 4 for me? It's right up on the board. No, I won't. And then on JKLM, could you have these sides for me? 2 on JM, 4 on JK, 6 on KL, and 8 on ML. Not in your groups, but real quickly by yourself. Could you find the perimeters of both of those for me? Real quick. Just find the perimeter of both quadrilaterals. Perimeter of ABCD? 10, right? And how about JKLM? 20. All right. So what am I trying to prove to you if two figures are similar? What's the ratio of the sides first? Look at all the side lengths and match one pair up. What's the ratio of the sides? 1 to 2. What's the ratio of the perimeters? 10 over 20, which is 1 over 2. So what am I trying to tell you? Whatever the side ratio is, it's the perimeter ratio. Okay, whatever the side ratio is, it's the perimeter ratio. Okay? So let's use that on number 4 before we call it a day and move on to homework. So these two are similar. Find the perimeters. All right, find the perimeters. Go ahead, find the perimeter of MNPQ. I don't need to help you there. Nine, 10, 7, 8 will be 34, hopefully.
34.
Thank you for confirmation. Everyone's 34? All right, now how can I find the perimeter of this smaller one here without knowing 3 of the sides and only knowing 1? What did we just learn above? The ratio of the sides. All right, so what's 4 matching up with then? 4, how do I know it matches up with 8? I can't visually do it. Help. I can't visually do it. W, right? WX would match up with QM. 8, yep. The ratio of the sides is the same as ratio of the perimeters, which is, I don't know, for the smaller one, and 34 for the bigger one. All right? Ratio of the sides, same as the ratio of the perimeters. And there you go. You got yourself a little cross multiplying. X equals, so I got a 1, 7 in the house. Sides and perimeters, same ratio. Questions, comments? All right, I would like to do number 2 with you on the homework right now, and then I'll let you go on your own. But I would like to do number 2 with you. I got to prove one. I just got to show you one last big point when you set up your own proportion. Yep, isosceles triangle, ADE. Yep, ABC's isosceles. Great. AB, ready? AB is 10. BD is 5. DE is 12. What's the length of BC? All right. Do you see 2 triangles in this diagram?
Yeah.
ABC and ADE, right?
Yeah.
All right. I need you guys, or I'm going to help you write the proportion now. Here's why I wanted to do this one with you. Hey, when you write a proportion, you can only use full sides in a triangle. Full sides only in your proportion. So everyone see where 5 is on BD? You should not be putting 5 in this proportion. Why not? It's not a full side. I only require full sides in a proportion. All right, zip it. All right, moving on. Name me 2 sides in one of the triangles. What are 2 side lengths in one of the triangles? Oh, one. Hi, George.
AE and BC.
AE and BC. You just gave me 2 different lengths from 2 different triangles. Which side are we trying to find?
BC.
You see what triangle it's a part of?
ABC.
Yep. So name me 2 of the sides from that triangle that you know.
AB and
Just, no, how long are they?
10 and 12. Oh, 10 and
10.
yep.
And what's the other side that we're trying to find on that one?
AC.
I don't know that though. I want ones that I actually have a value. So 10 and X, right? Those, you see those come from triangle ABC.
Yes.
Okay, come on, do better than that. Match them up now. Match them up with the bigger triangle. Here's where, ready? Don't get nervous. What would 10 match up with in the bigger triangle? Don't tell me 5, that's not a full side. Everyone see it matches up with 15, not 5. All right, 15. And side X matches up with what in the bigger triangle? Full sides only when you write a proportion. Go ahead, finish that one up and get going on the homework. You can do it with it right in your group. We still got plenty of time. Full sides only.